As far as motion is concerned, I went ahead and had you read this. We're going to be working with equations where we're going to be given like a position equation, okay? So first of all, when we say the word initially, what does that mean? What equals 0? Time equals 0, okay? If our particle is at the origin, what equals 0? Say it. Okay, our distance, and says since S of t is what our position is, when our position is 0, that means we're at the origin. Okay, now I want you to keep in mind that we are, this particle is just traveling back and forth one direction. So right and left, or up, down, up, down. We're going to focus on right versus left, but it can only travel along a line. It can't travel along a curve. Okay, so we're traveling back and forth on a line. Now, velocity is a measure of the amount of distance traveled over a period of time or a rate of change. How is that going to relate to our position function? We're in calculus class.
It's like change over time, so like ST, the change of ST over time.
Okay, and what is a way for us to describe an instantaneous rate of change? The derivative. So our velocity function is just the derivative of our position. Okay? That's an important concept. Physics people, maybe this is making more sense to you, or maybe you already knew that, I don't know. What is it going to mean if our velocity is 0?
Not moving.
We are not moving. Okay, our particle is still. Okay? If our velocity is positive, which direction are we moving, right or left? We're moving right. Remember, velocity is speed with direction. So if we have positive velocity, we're moving to the right. If we have negative velocity, we're moving to the left. Okay? Finally, acceleration is the measure of the rate of change of velocity. Okay, so acceleration is going to be the derivative of velocity, which can relate back to our position as its second derivative, if we really want to go that far, okay? But as long as you know that acceleration is the derivative of velocity, you're going to be all right. Okay? That's what we're going to do for the next 6 days. We're going to take everything that we've learned in calculus, and we're going to apply it to this situation: position, velocity, acceleration. Okay? So, let's get to work. All right? When we are given a graph, okay, we're going to have a t-axis instead of an x-axis, okay, and our y-axis is going to be our position, okay. You're probably not going to see the second or third quadrant at all, because where does time begin?
0.
At 0. Okay.
Did you say that?
Rectilinear motion. Okay. And some of this is on your buff sheet, okay, from yesterday. Some of this information. Okay. If we are reading a position time graph, okay, remember we talked about if our position is 0, we're at the origin. So here, when our position is 0, we are at the origin. Now, origin refers to maybe like the center of the room. Like if I'm pacing back and forth, the origin may be like the center of the room, okay? The origin isn't necessarily like the origin on an XY plane. Remember, we're moving back and forth just along a straight line, okay? So if this is 1, then right here, I am 1 unit to the right from the center, or the origin. And if this is -1, then right here, I'm 1 unit to the left from the center, or the origin. How many times does this particle hit the origin? It starts at the origin, it moves to the right, comes back, moves to the left, comes back. All right, now, you already have the information about velocity. It's on your gold sheet. Instantaneous velocity is the rate at which a particle's position changes, and it can be described by the derivative of the position. Okay, let's think about units. Okay, if we're talking about a position like in feet, and then we take the derivative with respect to time, then we're taking feet per so many seconds. Okay, does that make sense? Okay, so let's write a couple things down. Okay, and you have this on your gold sheet. So if S of t is position, which is our distance, right, then our derivative is velocity, which we're going to measure distance over time. Now remember, those of you who have had, well, all of you have had some sort of physical science, correct? Isn't that a requirement, physical science or physics? Yes, shake your head. Okay. You know that velocity has direction versus speed, which does not have direction. If we wanted to describe speed, what would we have to do to our velocity? Good. I already had you think about this concept last night, but let's talk about velocity positive versus negative velocity. If we have positive velocity, what's happening? Which way are we moving? To the right. If we have negative velocity, which way are we moving? To the left. To the left. Okay, so let's work with this here. Write this down. S of t is t cubed minus 6t squared. We're going to do a couple things with this. Okay. Keep in mind that position is describing where we are in relation to the origin, and velocity is describing which way we're moving. Okay, so this is that equation right there. Thank you. When are we at the origin? Grant, when are we at the origin? If we look at that graph.
When time is 6.
Time is 6, do you agree? Because our position is 0, that means we're at the origin. Anywhere else, Grant?
Time is 0.
Good. So since our position is negative from 0 to 6, our particle is to the left of the origin. And from 6 to 8, our position is to the right. And make sure you understand that it's our position. We're not talking about which way we're moving yet. Okay, now some of you, the wheels are already turning, okay, where we have negative versus positive velocity. Right. Logan, what would our velocity equation be?
Wait, so we take the derivative, so it would be 3t squared minus 12t.
Do you agree with that? Is the derivative 3t squared minus 12t? Okay. 3t squared minus 12t, that is our velocity. And here I have the graph for you. Okay. Please make note that this is a velocity time graph. The graph on the previous slide was a position time graph. Here we have a velocity time graph. Okay. Where is our velocity 0? Isaac, where is it 0?
0, 4.
Okay, and so Isaac, what does it mean if our velocity is 0? It's not moving, okay? Moving to the right means our velocity is positive. Connor, where is that happening?
Or velocity is positive.
Mm-hmm.
So, from 4 to 30.
Okay,
6.
not sure why it cut off on 6 there. Our other one went to 8, didn't it? I'm going to write 4 to 8. Okay? We are moving to the right from 4 to 8 because our velocity is positive. We are moving to the left from 0 to 4 because our velocity is negative. Okay? Now, what I want to do is I want to go back to that graph, the position time graph. Here's our position time graph. Could we tell from here when it was moving right and left? Okay.
Yeah, it's decreasing.
Okay, so where is it decreasing?
0 to 4.
We are decreasing from 0 to 4, which means our derivative is negative. Therefore, we're moving left from 0 to 4. Our position is increasing from 4 to 8, which means our derivative is positive, our velocity is positive, we're moving to the right. Okay, so you can read your graph and use your knowledge of calculus to help you out there. Okay. Speed, remember speed is the absolute value of the velocity, which means if any velocity is negative, it's going to make it positive. So this is the speed graph. Anything that's negative, it makes it positive. I'm going to come back to this graph very quickly. Our velocity is 0 at 4. What is happening at time equals 4? Obviously, we're at rest, but why are we at rest? And why does it have to do that? Okay. Look at this right here. Why does it have to slow down and stop? Because it's changing directions. Anytime we change directions, you're going to have a moment, an instantaneous moment where you have to stop, right? So anytime our particle changes directions, we're going to have a velocity at 0. Okay. All right, let's talk about acceleration. We already talked about how this is the rate of change of velocity, okay? Essentially, it's the rate of change of the rate of change, okay? So if we're talking about our position is distance, our velocity is distance over time, acceleration, what kind of units are we going to get there? Okay, we're getting distance over time, right? So we're getting a distance over time squared. Okay, so this is what we already talked about on our gold sheet, buff sheet. Our acceleration is just the derivative of the velocity, which you can also think of as the second derivative of position. Okay. We're going to talk about that second derivative because remember we know things about concavity. So even if we have the position graph, if we can tell where it's concave up or concave down, we can tell where the acceleration is positive versus negative. Now, physics people, does positive acceleration mean you are speeding up?
Mm-mm.
Why not?
You made it sound like it was
Does acceleration mean you are speeding up?
Wait, does acceleration mean you're speeding up, or does positive acceleration mean you're speeding up?
Does positive acceleration mean you're speeding up? Why not?
Well, you can be accelerating in the other direction.
You could be accelerating in the other direction of your movement. So, if we want to say that we're speeding up or slowing down, we have to think about the direction of our movement. So, if our velocity and acceleration have the same sign, meaning the velocity and acceleration are going in the same direction, then we can say we are speeding up. So if we are accelerating negatively and our velocity is negative, we are still considered to be speeding up. It's like you putting your car in reverse and hitting the gas. You're moving backwards and you're getting faster backwards. You're speeding up. Okay? Now, if you are moving in one direction but accelerating in a different direction, you have positive velocity but negative acceleration, that is going to cause you to slow down. You are backing up out of your driveway, so you're moving backwards, but you hit the brakes, so you're de-accelerating, right? You're accelerating in the other direction. You're slowing down. Okay? So acceleration does not specifically tell you if you're speeding up or slowing down. If I ask you about speeding up or slowing down, you have to consider velocity and acceleration. Okay, let's go back to our original position function. Logan told us that our velocity function was 3t squared minus 12t. Sammy, what would our acceleration function be?
16 minus 12.
6t minus 12 would be our acceleration function. Okay. Which is right there. Essentially, we have negative acceleration from 0 to 2 and positive acceleration from 2 to 1. So we're going to say from 2 to 8. Okay. Now, let's talk about our position curve and how it relates to those intervals. What's happening from 0 to 2 on our curve? What's the concavity? We have a concave down piece, which means our second derivative is negative. From 2 to 8, we are concave up, which means our second derivative is positive. Okay, so from a graph, we're going to be able to tell, from a position time graph, we're going to be able to tell where our function is to the right or left, if it's moving right or left, and if the acceleration is positive or negative, just from our knowledge of calculus. Okay. So where this really gets exciting is when we get to do it with algebra. Okay. Now, we've had a lot of practice reading graphs, and that's why I gave you the assignment that I did last night, is so you could read. Essentially, I made you read a velocity graph, but you didn't know that it was a velocity graph. We're going to go ahead and do this with some algebra. Okay? I'm giving you a position function, and I want to know everything about it. Okay, I said analyze the particle for time is greater than or equal to 0. So when I say analyze, we're going to figure out the velocity. We're going to figure out where we're moving right and moving left. We're going to figure out when we're standing still. We're going to figure out the acceleration. We're going to figure out when we're speeding up versus slowing down. Okay, so what I'd like you to do, you and your group, I want you to write down the velocity function, skip a few lines, and then write down the acceleration function. Compare it to your neighbors. Okay. Josie, what's your velocity equation?
16
squared minus 42t plus 60. Great. And Aaron, what's your acceleration?
12t minus 14.
Okay. In order for us to figure out where our particle is moving right versus left, what do we need to do with our velocity equation? We don't have a graph, we just have the equation. What do we need to do to it? Say a letter. Set it equal to 0. We need to set it equal to 0, and then we can figure out where our velocity function is positive versus negative. So we'll set it equal to 0. Probably a good idea to do what? Okay, take out that 6. So we have t squared minus 7t plus 10. That's nice, isn't it? What do we factor this to? Minus 2, minus 5. Right? Okay. Then what we can do, remember this, right? We can put these, we can put these on a number line. Okay, so less than 2. If I plug in a number less than 2, is that going to make our velocity positive or negative? Positive. If we plug in 0, we get a positive velocity. That would be about the easiest one to plug in, right? Okay. How about between 2 and 5? If we plug in like 3, are we going to get a positive or negative velocity? And what about at above 5? If we plug in 6, positive or negative velocity? What? Thank you. Okay. What does this mean? What is happening at time is 2 and 5? Alex? Okay, so what does it mean about our particle? Like if we were watching our particle, what happens to that particle at those times? Okay, we're changing directions because because these are changing, right? Okay, so we're changing directions. Also, we can say that, so our particle is stopped at time is 2 and 5 because we are changing directions, because our velocity is 0. Okay? Now, we could have velocity of 0 without a change in direction. Like I could walk and stop and keep walking in the same direction, but most of the time we'll see that change in direction. Okay? Now, technically, we only care about 0 to infinity, right? So our particle is moving to the right when time is from 0 to 2 and when time is from 5 to infinity. We know that our particle is moving left when time is between 2 and 5. Between 2 and 5, we have negative velocity, so our particle is moving left. Every other time, we have positive velocity, so our particle is moving right. What do you think so far? We're not done with the problem, but what do you think so far? No, because we still have to analyze acceleration. Okay? But look, we have a linear equation for acceleration. That's not going to be a problem, right? Okay, so if we want to analyze acceleration, what are we going to have to do for the acceleration equation? Set it equal to 0. So let's see, we can factor out a 12. No, we can't factor out a 12. What can we factor out? Well, it's not gonna matter. If 42 equals 12t, what is t? 7 halves or 3.5? I like 3.5 because that, like, if time is seconds, we're probably gonna say 3.5 seconds, not 7.5 seconds, right? Do you agree with me there? Okay, so let's put that on a number line. Okay, do we have positive or negative acceleration when we're less than 3.5? Negative acceleration, positive acceleration past that. Okay, and really we only care about from 0 on. Now, I want to analyze when we are speeding up versus slowing down. Does this just mean positive acceleration versus negative acceleration? No. Remember, our acceleration needs to be in the same direction as our velocity if we are speeding up. If our acceleration and velocity are in opposite directions, we are slowing down. All right? So, from 0 to 2, we have positive velocity. From 0 to 2 here, we have negative acceleration. What does that mean? We are
Different
slowing
signs.
down. Okay, so we are slowing down between 0 and 3.5. No, 2. Sorry. Now, from 2 to 5, we have negative acceleration. Excuse me. Negative velocity. All right? You know, I did my work kind of all over the place. It could be helpful if you draw your velocity and acceleration together. Okay, I'm going to go ahead and do that. Was it positive, negative, positive, right?
Yes.
Now it's a lot easier to compare when they're right on top of each other, right? So now we see from 2 to 3.5, we have negative acceleration and negative velocity. So between 2 and 3.5, we're speeding up because acceleration and velocity are in the same direction. Okay? Then we can see from 3.5 to 5, velocity is negative, but acceleration is positive. So once again, we are going to be slowing down. But then from 5 on, we're accelerating positively and we're moving positively, which would mean we are speeding up. Okay, the only thing that I have taught you today is the relationship between position, velocity, acceleration, and maybe the concept of speeding up versus slowing down. All of the calculus you have done before, okay? Which is why we save this to last, because we get to practice all the calculus that we've done in a situation that is very realistic, right? Oh, yeah? He says with confidence. Okay.